Welcome to InfoDex. Today we're going to be doing the 2008 CAP problem part C question 3. This is the last question in the 2008 problem contest. So let's get started. So in problem 3, we have an arrangement shown in figure 3c. An object is hung from a string with linear mass density mu equals to 0.002 kilograms per meter that passes over a light pulley. The string is connected to a vibrator of constant frequency f, and the length of the string between point P and the pulley is L equals to 2 meters. So when the mass of the object is either 16 kilograms or 25 kilograms, the standing waves are observed. However, no standing waves are observed with mass between these values. The speed of a transverse wave in a string experiencing the tension T is given by V equals to the square root of T over mu. So I want to find the frequency of the vibrator, and what is the total number of nodes observed along the compound string at this frequency, excluding the nodes at the vibrator and at the pulley, and the largest object mass for which standing waves could be observed. So first, you can look at the standing waves, right? Note the nodes. Like this is a fundamental frequency for a line. It goes like this, right? This point is a node, right? You can see the lambda for this is going to be equal to 2L. You can derive an equation that lambda is just equals to 2 over n nodes L, where nodes are only nodes in the middle, not including 2 at both ends. So we can write the two equations. We know frequency is fixed, right? So constant frequency. So we know velocity is just T over U. So for the first equation, we can write square root of T1 over mu. And mu is constant. T1 over mu is going to equal to a constant frequency times the wavelength, which is just a 2 over NL. For the second one, right, T2 over mu equals to frequency over 2 over, well, we see here, right, there's no mass between these values, so we know these two are they follow each other, so there's no between them. So if this has n, this one will have n plus 1, so it will be n plus 1L. Now we get equation 1 and equation 2. So we can cancel a lot of the variables by just simply dividing equation 1 by equation 2. So let's do that. So we get 1 divided by equation 2. That will give us, well, we can cancel out everything here. So we get T1 over T2 is equal to, put this up there, n plus 1 over n. Well, you know, T1 over T2 is basically just, the tension is just mass times the acceleration of gravity. So you can cancel the gravity, you get equals to mass 1 over mass 2. Now I want to find mass 1, is it 16 kilograms or 25 kilograms? So let's first look at this equation. So now n is bigger, right? So that means the value on the right side must be smaller, and this will be bigger. So I want this to be bigger, so that means tension in here must be bigger. So this must be a bigger mass. So this is 25 kilograms. Similarly, this will be 16 kilograms. So we can solve, right? This M1 is 25 and 16. Take the square root, it's going to 5 over 4. Then you can times any over here, so 5 over 4 n and minus over the other side. So we get n plus 1 equals to 5 over 4 n. Now we do put this on the other side and divide by negative 1 over 4. You get n, which is equal to 4. So that's the number of nodes between the two ends at the first frequency. So we found part B already. So part B is 4 nodes. Now frequency, we know n, right? So we can just plug in here. Let's write the equation again, but we rearrange for frequency. So we get frequency, which is going to be equal to the mass 1, gravity, mu. Now move that over there, so it's times n divided by 2L. Now we plug in n equal to 4, L is equal to 2 meters, M1 is 25 kilograms, G is 9.81, mu is 0.002 newtons per meter. Calculate it, we get the frequency is 350 hertz. So we know here is 250 hertz, the vibrator. So I want to find the largest mass for which standing waves could be observed, right? So the largest mass will be, this thing will be really big. So we want this to be as small as possible. You know, n can go below 0. So the smallest n is 1. So this will be largest when n is 1. So let's write the equation with n is 1. So you get T is just mg. So mg, some arbitrary mass, over linear mass density is equal to the frequency, which is fixed, we know here, times 2L. It's divided by 1 technically, but it's just 2. So let's just square both sides. We get mg over mu is equal to frequency squared times 4 times L squared. Now we can put mu up there and G down there, so we get mass is equal to 4 frequency squared L squared mu over G. And solving this, plugging the values we know from the question up here, we get the mass is roughly 400 kilograms. So now we know this is 400 kilograms. And that's it.